this session of GATE score booster. So now we will start the session, and please reply me, is the audio and video clear or not? Please reply in the chat box, beta. Is audio video clear, everything? Okay, so let me check. Okay, so now my dear, so we'll start this session is approximately 3-hour session, and during this session we solve some very good problem for this one, and also one second. Thank you. Okay, thank you, Sandeep. Thank you, Saurav. Thank you for this. Okay, so first of all, you know this thing that if you why, because machine design already you already and matlab you have to the subject of machine design already study in the semester examination. So, and now it is as per as GATE syllabus, my dear, there is a difference between the numerical type, that means the difference between the numerical of machine designing for the semester and for the GATE. In the semester you have availability of a design data book, but in the GATE there is no any type of design data book is there. Number first thing. Number second thing is that, so how to solve that problem? The problem is very easy. Only the concept have a mixing concept, the concept of basic strength of material and the concept of mechanical property. That means you know the what is the strength of the material, what is the stress of the material. So one thing is very clear before starting the subject, stress and strength, all the chapter there are discussion two common term, stress and strength. What is the stress and strength? What is the single line difference between stress and strength? Stress and strength. So beta, strength is a mechanical property. Strength is a property, but stress is not a property. Number first thing. So we design any component below and equal to its strength value, and to find the suitable parameter for that one. Okay. So in each and every chapter, the strength value, the maximum strength value, that means what is that? If there is a ductile material is there. If there is a ductile material is there, so we have to design the strength. So what is the strength? Yield strength and ultimate strength. But during the, if you design the material, against it the failure or against is a plastic deformation, so the material below the yield point. If the design the material against is a fracture like a brittle material, so you have to design the material below the ultimate point. Okay, so there are two criteria is there. So first, the chapter first, what is the overview today? We have to take overview. What is the overview? Today's overview. 1 second, beta. Okay, 1 minute. Okay, so today we will discuss. The some topics. First one is, okay, no problem. First topic is your design against static and dynamic loading condition. That means design against load. My dear, if you design any machine component, if you design any component of a mechanical member, the prime input is your load. The prime input is your load. According to load, you have to design that material. That means in the machine design, we have to categorize two type of load. Number first is the static load, other is dynamic load. And we have to design according to these two loads, that means static load and dynamic load. So we'll start number first, the design against the loading condition. Number second, we have to design of bearing, general bearing. Number third, design of joints, that means rivet and bolted joints and welded joints. Then design of gear, particularly for the spur gear, and then design of a clutch, and then design of a, what is the power transmission, that means clutch and brake. We have to design. Okay. Good evening, beta. Good evening, good evening. Everyone, welcome to this session and please be patient. I will discuss. See, what is the main motive of the discussion? See, the problem is very simple in the GATE exam, but the approach is very clear. So, while you are solving the problem, you have a different approach. But what is the suitable approach within the prescribed, within the given span of the time? That is the very important thing. So, we will try to follow that situations. That means you have to try to solve the problem within 2 and 3 minutes, within 2 minutes also. Okay. So first question is your MSQ type question. What is that? See, my dear, the first question is, see, I left this question for you only. Okay. So please read this question. Please read the today's first question, MSQ type question. Okay. What is that? Which one of the following statement are correct? Please read the statement carefully. Please read the statement carefully. Okay. What is the, see, Rankine theory of failure is generally recommended for brittle material. Option number B. According to maximum principal stress theory, that means MPST, failure of a component subjected to a biaxial or triaxial state of stresses occurs if the maximum principal stress is equal or exceeds the yield or ultimate strength of the material. Option number B. Statement C is distortion energy theory, DET या von Mises theory is of a failure gives the excellent prediction in terms of safety of a component when the component are in a ductile in nature. Statement 4, maximum shear stress theory is used to ensure the safety of aluminum bar subjected to static loading. Please, which of these statements are correct? Please tell me. Which of these statements are correct? Tell me. Everyone, please. Which of these statements are correct? Please read this one. B only? B, only B. No, it is wrong. These are the MSQ type question, beta. These are MSQ. More than one option is correct. A, B and C. Rohan. A, B and C. Not for D. D is Rohan. A, B, D. A, C, D. Okay. A, B, C. A, B, C. My dear, you all are wrong. All options are correct. This is the first question. All options are correct. See, Rankine theory is generally it is used for a brittle material. This is the statement of MPST, maximum shear stress theory. What is the statement? According to the maximum principal stress theory, failure of a component subjected to biaxial or a triaxial, the state of stresses occur if the maximum principal stress is equal or exceeds the yield or ultimate strength. This is also correct. Number third, distortion energy theory, DET, या von Mises theory of a failure gives the excellent prediction in terms of a component when the component are in ductile nature. My dear, so MDET is applicable for the ductile material. Yes, D option. See, see, my dear, this is very good. Very good, very good. I will discuss D option. Maximum shear stress theory, that means MSST. Okay. Aluminium is which type of material? Please tell me, beta. Tina, please tell me, aluminium which type of material? Ductile material or brittle material? Please tell me. Aluminium is a ductile material or brittle material? Please tell me. Everyone, please tell me. Aluminium is a ductile material or brittle material? Please tell me, everyone. Aluminium is a ductile material or brittle material? Everyone, please tell me. Rahul Kumar, good evening, beta. Rahul, aluminium is which type of material? Which type of material of the aluminium? Aluminium is a ductile material. Aluminum is a ductile material. No brittle. Ductile. Aluminum is a ductile material, beta. So, ductile material, the maximum shear stress is used to ensure the safety of a bar of subjected to static loading. This is the static loading, okay? Why? Because this theory of failure, maximum principal stress theory, maximum shear stress theory, maximum distortion energy, these all are theory of failure against static loading. Yes, very good, Rahul. Against static loading. So all this theory against static loading, this is correct. Now, aluminum is a ductile material, and for the ductile material, the theory of failure is best suitable for the MDET. Yes, but MSST, maximum shear stress theory, gives the most conservative result. So the MSST and MDET both are used for the ductile material. Clear? Clear? Tina, clear, beta? So all are the options are correct. Please tell me, any confusion for this one? All are the theory. Okay? Now go to the next problem. Is there any confusion? Right. Very good. Next question. Please try to solve this question. 2 minutes. Please try to solve this question 2 minutes. If a rod is subjected to bending moment of 3 kilonewton meter and a twisting moment 1.8 kilonewton meter, the diameter of the rod according to the maximum principal stress theory, MPST. This is your NAT type question, numerical answer type. Okay? If the yield stress it is given and the factor of safety is 3, so what is the diameter? And you have to find the diameter in mm. Please. Acha, how B is correct? Okay. Please try to another, Rahul, I will discuss. Other than you have to try this one. Why B is correct? Yes, what is the B? B is the statement. Rahul, B is the statement of maximum principal stress theory, MPST. Maximum principal stress theory, what's this? Failure of the component. That means failure of the component is done by the biaxial or triaxial state stress. If the maximum principal stress theory, that means sigma 1 is greater than or equal to of yield or ultimate, that means SYT or SUT. So material is fail. And for the safe, the maximum principal stress sigma is less than equal to SYT or SUT. For the safe, this is the statement. Clear, Rahul? This is the statement. Rahul, it is clear, beta? This is your statement of maximum principal stress theory, MPST. Clear? Now, try to solve this problem. Okay. Try to solve this problem, beta. Now, what is this in this problem? There is a shaft. This is your shaft is there. Okay. This is your shaft. Okay. This is your shaft. Now, this shaft is, what is that? Bending moment it is given, that shaft, let's suppose this is fixed, and this shaft, the bending moment, let's suppose MB, it is given how much? 3 kilonewton meter, and the twisting moment, also there is a twisting moment, let's suppose MT, twisting moment it is given how much? 1.8 kilonewton. Okay, this is given. Now, so, and yield strength it is given SY 420 megapascal, yield strength it is given. Okay, factor of safety it is 3, and we have to find the diameter of this shaft. Okay, which theory? Maximum principal stress theory, according to maximum principal stress theory, MPST. Please find the answer. So my dear, there is no any transverse load, only bending and twisting moment is there. So bending it is there if you take any element of this bar. Let's suppose this is your neutral. Let's suppose if you take any element on this bar, okay, this is your element. So there is a bending, it will produce a bending stress sigma x in this direction, and there is a twisting, so it will produce torsion tau xy. This is your state of stress of this type of loading. If you take any element point on this bar, so there must be a, why? Because if there is a bending, upper part is tensile, lower part is compressive. If you take upper part, make a tensile nature. If you take a lower part, there is a compressive in nature, so make incompressive nature, and there is a torsion, so there is a torsional shear stress. Clear? In this one, there is no any stresses in y direction. Sigma y is 0, and there is also sigma z is equal to 0. So this is your x direction and this is your y direction. Clear? Clear? Now, how to find from this bending moment? We have to find the bending stress. Okay, diameter 61.8. Correct, Rahul? Rohan Mandal. Correct, beta? Correct. So sigma b is what? What is the, there is a formula, bending moment into neutral axis from y divided by moment of inertia. So this is the bending moment and y is the distance from the neutral line. Wrong. 0.47, Rahul, wrong. So if you put bending moment 3 cross 10 to the power 3, why? Because this is your kilonewton into what is y? Y, it is what? If this is your cross section, so y it is your maximum distance and y equal to d by 2. D by 2. Y equal to d by 2. So here d by 2 is there, divided by what is the moment of inertia for the shaft, solid shaft, pi by 64 d4. Okay. If you solve this one in the term of d, so this is 30.5 cross 10 to the power 6 divided by d cube, and this is what? This is your sigma x. Okay. Now you have to find shear stress tau. So now you have to find tau. So shear stress tau is equal to, what is that? Torsional moment into radius r divided by polar moment of inertia. You know this from the flexure formula. So what is the torsional moment? 1.8 cross 10 to the power 3. What is r? R is d by 2 divided by, what is the polar moment of inertia of solid shaft? Pi by 32 d power 4. So see, this is your moment of inertia, pi by 64 d4, and this is your polar moment of inertia, pi by 34 d4. If you rearrange it, this is your 91, this is your 90.16 cross 10 to the power 6 divided by d power q, and this is what? Tau xy. So this is your element in x direction, this is your in y direction, this is your sigma x, and this is your tau xy. So you have, so we have to find the, and what is the maximum principal stress theory says that? MPST says that if the material, when the material is safe, when the maximum principal stress is less than their yield, less than or equal to their yield strength value. So we have to find the principal stress maximum. So let's suppose sigma 1 maximum is what? Sigma x plus sigma y. You know this formula, plus 2 root under sigma x minus sigma y by 2 whole square plus tau xy whole square. You know this. Put this value here. So sigma y is 0. Sigma y is 0. Put this value. So this is your sigma x by 2 plus root under sigma x by 2 whole square plus tau xy whole square. put this value, and what is sigma, and what they says that according to MPST, maximum principal stress theory says that the maximum shear stress, yes, very good Rohan, maximum shear stress, maximum principal stress sigma 1 is less than equal to SYT, and SYT, so if we equate it, divide by factor of safety, divide, this is your SYT. So if we, so what is that? That means sigma 1 is equal to SYT divided by factor of safety, divided by factor of safety. So what is the sigma 1? So sigma 1 it is there, sigma 1 it is there, and factor this SYT it is given how much? SYT 320 megapascal, that means this is your Newton per mm square, and factor of safety 3. So 420, this is your 420 divided by factor of safety 3, and this is equal to this one, sigma 1. Put the value, sigma x you have, sigma y, tau xy you have, put all this value, equate this one, find the diameter. So 420 divided by 2, 3, this is equal to 30.5 cross 10 to the power 6 divided by 2 d pe power q plus square root of 30.5 cross 10 to the power 6 divided by 2 d pe power q whole square plus tau 9.16 cross 10 to the power 6 divided by dq whole square. Now one is only unknown, d. So diameter is 61.8 mm. I think this is clear. Everyone please tell me. Rahul, please tell me. Everyone please tell me. Rohan, very good beta. Rohan, I am happy. Rohan, you are very good. Rahul, clear beta. Everyone please reply in the chat box. Everyone please reply in the chat box beta. This is clear or not? First question. So diameter of the shaft is, this diameter of the shaft is 61.8 mm. Clear everyone? This is clear, this question? Everyone please? Clear. Clear. Now next. Yes, try to solve this problem. Everyone, I give you 2-minute time. Try it. Try it. What is that? The state of stress at a point is a given in megapascal, and this is a state of stress is given. The yield strength of the material is 360 megapascal. Factor of safety according to MDET, distortion energy theory. MDET. Please try to solve. What with Rahul? What you say that, sir? M equivalent you can also use, no problem. Equivalent torque, but equivalent torque, there is one problem also. We can solve this. This question you also try to solve M equivalent. Equivalent moment is there. You can solve this one, no problem. Very good. Again, but for the equivalent, this you have. So equivalent you have to, but there is your equivalent. So equivalent moment. So for the M equivalent, that means binding moment equivalent, yeah, torsional equivalent. So for the torsional equivalent, you have to apply 16 tau by pi dq like that, and you can find it also, no problem. Please check it. First check it. Okay. But what is my perspective is that you try to solve this one. Why? Because M equivalent is a maximum. So you can find it, no problem. You can put here and try to solve. Very good. कर सकते हैं. You can do, no problem. आप कर सकते हो बेटा, no problem. Okay. Now, next one, please try to solve this MDET. This is your state of stress is given. So, what is the notation of this state of stresses? This diagonal is your normal stress and this is your shear stress. So, here sigma x it is given 100, it is in megapascal, you take megapascal, no problem. And sigma y it is given 40 and tau xy it is given 40. This state of stress it is given. Okay, this diagonal represent normal stress and this diagonal represent the shear stress. Okay. Now, what is MDET beta? Please tell me. Maximum distortion energy theory. What is that? This says that SYT yield shear strength in tension divided by factor of safety is equal to half of sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. That's it. That's it. This is your MDET. Just remember this formula. Here, only two state of stresses is given. Third state of stress is not given. So, put sigma 3 is equal to 0. Put sigma 3 is equal to 0. Put sigma 3 is equal to 0. Why? Because this is your biaxial state of stress. Biaxial state of stresses. So, third is 0. Okay. Factor of safety is 3.4. Correct. Correct, Rohan. Correct. Okay. So, put, so here, okay. Now, so third one is 0. So, third one is 0. Biaxial state of stresses. So, sigma YT divided by factor of safety, third you can take 0. So, if you third you can take 0, this is in the form of sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. That's it. Take third is 0. Take third is 0. Clear? Why? Because this is a biaxial state of stress. So, here it is. Now, we have to find sigma 1 and sigma. Why? Because this is not a principal stress. So, we have to find sigma 1 and sigma 2. So, sigma 1, 2. What is that beta? Sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. Clear? Put this value, sigma x is 100 plus this is 40 divided by 2 plus minus square root 100 minus 40 divided by 2 whole square plus tau, it is your 40 whole square. So, how much it is? So, sigma 1 measure, this is your 120 megapascal, sigma 2 it is your 20 megapascal. Clear? 20 megapascal. So, according to apply, so what is that? Square root of sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equal to SYT divided by FOS. Put this value here. Put this value here. Sigma 1 it is your 120 square plus 20 square minus 120 into 20 is equal to SYT, it is given 360 divided by factor of safety. So, from here you can easily find factor of safety is equal to 3.4. Clear? Clear everyone, please? Yes. Yes, Rahul. Very good. Very good. Very good, everyone. No, beta, you cannot say like that. See, you cannot say, Mandal, beginning value of the matrix principal stress. No, you cannot say. It is not like a principal stress. Here it is not the state of stresses at a point. My dear, I am telling you, Mandal, you are very good question. See, state of stresses at a point. Please tell me one answer. If there is any bar, we apply the load. How many maximum state of stresses is there? Please tell me. At this point, how many state of stresses is there? Please tell me, Mandal. Rohan beta, please tell me, if there is a shaft is there and if you apply the load at this point, what is the maximum number of state of stresses? Please tell me. What is the maximum number of state of stresses? Please tell me, Rohan. If there is any mechanical member, if you apply the load at that point, how many maximum number of state of stresses? This is the interview question. What is the maximum number of stresses? Please tell me. Please tell me. 9. What is that? 9. That means sigma x, sigma y, sigma z. This is your sigma tau xy. Like that, tau xz. This is your tau yz, yx. This is your tau yz. Like that. So there is a, yes, 9 state of stresses. Yes, there is a 9 state of stresses is there. Clear? 9 state. So this state of stresses is not a principal state of stresses. This is a normal state of stresses. Yes, 3 cross 3 matrix. 9 is there. So 9 state of stresses, sigma x, sigma y, sigma z, tau xy, tau y, like that. 9 is. So that is not a principal stresses. So mind it, it is not a principal stresses, beta. Clear, Rohan? Yes, eigenvalue, it is a principal. Very good. Eigenvalue, if you find the eigenvalue, that is your principal stresses. You are right. Eigenvalue of the matrix is the principal stresses, that is correct. But this matrix is not a principal stress. Rahul, you are right, beta. Correct. Rohan, you are right. That means eigenvalue of this matrix. If you find the eigenvalue of this matrix, that is your principal stresses, that is correct. Clear? So can you easily find for the eigenvalue. But we are not much more bothered about the mathematics. You are right. Very good. So in generally we have to solve like that. Okay. Clear? So you have to find the factor of safety, that is your factor of safety. Now the next question is this one. Please find it, this question. This question is NIT type. Please. A given steel has identical yield strength of 700 megapascal in uniaxial tension and uniaxial compression. Clear? If the steel is subjected to pure shear stress, pure shear stresses such that the 3 principal stresses is like that. That means sigma 1 is positive sigma, sigma 2 is 0 and sigma 3 is minus sigma. Clear? And this ranking is given. Sigma 1 is greater than equal to sigma 2, sigma 2 is greater than equal to sigma 3. Then the stress sigma, they are asking, in megapascal for the initiation of the plastic yielding. This line is very, initiation, just start. Initiation of the plastic yielding in the steel as per as von Mises yield criteria. As per as von Mises yield criteria. So what is the von Mises? Von Mises yield criteria, that means MDET. MDET, maximum distortion energy theory. Von Mises is the maximum energy. These are the scientists One miss is the scientist. Scientist name also there sometime in the gate they may supposed to be asked. But one misses, that means maximum distortion energy. Please find it. Is so sigma you have to find in megapascal. Please find it. 2 minutes. Start. Please start. 2 minutes, beta. What is the sigma value? Please start. Apply this MDET. What is the MDET? SYT divided by factor of safety is equal to square root of half sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. Please apply this one. 440. Correct, Rohan. Very good, beta. Very good. Very good. Very good. I am very happy. So, what is that? MDET. Okay, MDET. Now, what is the factor of safety here? 1. Why? Some student says that, sir, if the factor of safety is not given, we take 1. It is not like that. This says that for the initiation, just start. So, for the just start, initiation of the plastic yielding, so just start. Plastic yielding, when the plastic yielding is start? When the plastic yielding is start? At and after the yielding. At and after the yielding, the material behaves, yes, initiation. Very good. So, this is 1 now. So, what is that? That means, since for the initiation of plastic yielding, factor of safety is equal to 1. Put this value, that means sigma YT is a square root and it is given 1 by half. So, sigma is there, sigma 2 is 0, so 0 square plus 0 and sigma 3 minus, so plus sigma square plus minus sigma 3 minus sigma 1 square. Okay. Solve this one. So, this is your 2 sigma YT square is equal to sigma square plus 4 sigma square. So, this is your 6 sigma square. So, 6 square is equal to sigma YT square by 3. You can easily find also sigma is equal to sigma YT by root 3. That means 700 by root 3, that is your 404.14 mega. Now, you can also solve within 1 second. How? See, there is your subjected to pure shear. Very good. So, for the pure shear, you can solve this question within 1 second also. This is a very detailed solution. Why? Because sometime I am telling you in the machine design, directly use the formula, it will give the very low feel. But after you have explaining this thing and then we have to apply the trick, that is good. What is that? For the pure shear, okay. So, for pure shear. What is the condition for the pure shear according to the MDET? See, for the pure shear, that means if this is your element and this element there is a pure shear, that means this is tau xy, let's suppose. Okay. So what is the that means for the pure shear, what is the Mohr circle? Mohr circle is a circle and which is passing through at a center, passing through at a center. That means we will discuss this thing. So if this is your tau and this is your sigma, so for the pure shear this is your circle and this circle is at a center. So what is this one? This is your sigma 1, this is your sigma 2 and this is your tau max, let's suppose, and this tau max is what beta? Tau xy, maximum shear stress, and that means this sigma, that means this sigma 1 is equal to tau xy positive, sigma 2, yeah, you can say that sigma 2 is equal to minus of tau xy, negative it is there, and sigma 3 is equal to 0 for this state of stress, sigma 1 equal to sigma, yes, correct, correct. That means if you have SYT, so if you put this value in this one, so this your sigma YT is equal to root of 3 tau xy, and this tau xy is your sigma ys, yield shear strength, yield shear strength. So according to maximum distortion energy theory, yield tensile strength is equal to, that means yield shear strength is equal to 1 by root 3 of sigma YT. This is according to maximum distortion energy theory. Yes, circle is at center. So this is according to, just you put SYT value it is given, divided by root 3, there is a SYS. There is a SYS, and that use your answer. Clear? Just put this value, that is your answer. Clear beta? Okay. Okay. So this is your, let's suppose this is your sigma, that means sigma 1 is equal to sigma, let's suppose sigma 2 is equal to 0 and sigma 3 is equal to minus of sigma. This is the state of stresses, and this sigma is nothing, this is your tau max, magnitude tau max. Clear? Clear? Okay. Now, so this is clear, this thing is clear, apply just this one, direct formula. Yes, shape ellipse, very good Rahul, MDET, not ellipse, inverted ellipse, yes, very right, inverted ellipse, that means this is your inverted ellipse, that means ellipse is inverted at a 45 degree, and this line is your, what is this line, please tell me, what is this line, please tell me. Okay, I will ask something. If you draw the MDET, that means this is your ellipse. This will look like that, ellipse, okay? This is your ellipse. This is your ellipse. This is your SYT, SYT, SYC, SYC. If you draw a line which is at 45 degree of this one, what is this line beta? First tell me, everyone please. What is this line? Rohan, Rahul, everyone please beta. What is this line? What is this line? Please tell me. What is this line? Please tell me. Please tell me. This is called shear diagonal. What is the equation of this line? Please tell me. What is the equation of this line? That means, no, that is negative. That means SYT divided by SYC is equal to -1, not 1. -1 beta. Okay? Minus. Okay? SYT is equal to minus of SYC. Correct. This is your shear diagonal. Clear? This is according to MDET. Clear na? Clear? Rohan, clear beta? Clear beta? Rohan? So this is your SYT divided by SYC is equal to -1, not 1. Okay? -1. Why? Because slope is negative. Slope is negative. Okay. Now next, try to solve this problem. A steel bar of a diameter 55 mm, okay, is subjected to an axial tensile load of 40 kilonewton and a twisting moment of 1.6 kilonewton meter. The bar material has yield strength of 200 megapascal. The factor of safety according to von Mises theory. That means, please find it. 2 minutes. Please find it, beta. Please find it. The steel bar of a diameter 55 mm is subjected to axial tensile load and twisting moment. Okay? Let's suppose this is your material, this is your bar, and in this bar apply axial load P and there is a twisting moment MT. Clear? So if you take any state of stress at this point, state of stress, so this uniaxial, so this produce axial tensile sigma x, and this torque will produce torsional shear stress tau xy. That's it. Here sigma y equal to sigma z equal to 0. This is your x direction, this is your y direction. Okay? This is your state of stress. Now, please find it. Please find it with a factor of safety, everyone, please. See this one. According to MDET, what is the MDET? SYT divided by factor of safety is equal to square root of half sigma 1 minus sigma 2 whole square. Please you solve sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. Please try to solve yourself, okay? Here, this is the this is your uniaxial, na? Not biaxial. This is your uniaxial. So in this condition, we have to find sigma A and sigma B. Principal stress, that means sigma AB. What is that? Sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. From here you have to find sigma A and sigma B. So sigma A you have and sigma B you have. So sigma A is your major, sigma 1. Sigma B is minor, that means sigma 2. and sigma 3 is equal to 0. This is your state of stress. Put this value here, put this value here, put this value here. So if you put this value here, so sigma yt divided by factor of safety square root half sigma 1 minus sigma 2 whole square plus sigma 2 minus 0 whole square plus 0 minus sigma 1 whole square. Okay, solve this one. If you try to solve, this is like that. Sigma yt divided by factor of safety, this is equal to, if you solve, sigma 1 square plus sigma 2 square minus of sigma 1 square. You like that. So this is your principal state of stresses. Factor of safety is, 1 second beta, I will check. Factor of safety, 1 second. No, wrong. Factor of safety 2.3. Answer is 2.31. Wrong, Rohan. Okay. So this is according to principle. Now, but it is not, it is in terms of principle. It is in terms of normal stresses. So in terms of normal stresses, the formula is like that. Sigma x square plus sigma y square minus of sigma x sigma y plus 3 tau xy whole square. Always remember this one. This is your formula. This one. This one. Always remember. MDET. Clear? If you don't know this one, you cannot solve this one. Can never solve. Okay? Why? Because this is your normal stresses. This is not a principal stresses given. Normal stresses given. Okay? We'll try to solve this problem. Okay? So from here, you can try like that. Please see this thing. What is that? Given. What is given? Diameter 50 mm, load applied 40 kilonewton, torsional moment 1.6 kilonewton meter, SY yield strength it is given 200 megapascal. So if the load it is given, from this one you can find stresses, axial stress. What is that? Load upon area. Load is how much? 40 cross 10 to the power 3. Area pi by 4 d square, d it is your 55 no 50. 1 second. In the question what is given? 55. So put 55 here. It is your 16.8 megapascal. Please check it, counter. Okay. Now, from this torsional moment, we have a torsional shear stress tau, and this is your maximum. So 16 mt, you know that, divided by pi d ke power q. You know that this thing torsional rigidity. Yes. Yes, 2.3. Correct. Correct, Rahul. So from here, 16 mt it is your 1.6 cross 10 to the power 3 and 1.6 cross 10 to the power 3 it is in Newton meter, but here we have to find mm. So again you have to multiply 10 to the power 3. Don't miss the unit. Divided by pi d 55 ka q. How much it is? 49 megapascal. Clear? Now, and we know that according to MDT. So this is your sigma x and this is your tau xy. Okay. So sigma yt divided by factor of safety, just now we have seen that sigma x plus sigma y is 0 here. So root under sigma x square plus 0 minus 0 plus 3 tau xy whole square. This formula. So here SYT is 200 divided by factor of safety is equal to sigma x is equal to 16.8 whole square plus 3 tau, it is your 49 whole square. If you put that factor of safety, it is your 2.31. Clear? Clear, beta? Everyone please tell me. Clear? Rohan, Rahul, everyone please. This is clear? This is clear, beta? Okay. So this is according to your maximum distortion energy theory. So you always remember these two form of the formula for the two dimension. Sigma 1, this is in terms of principal stress, and this is in terms of state of stresses. This is in terms of state of stresses, and this is in terms of principal stress. Clear? Okay. So this is your things. Clear, beta? From here you can easily find. Okay. You can solve according to this one, sigma 1, sigma 2, sigma x. Okay. Now the next problem is this one. Please try to solve this problem. हाँ, MSST में 4 आता है, बिल्कुल राहुल, MSST में 4 आएगा, but correct हो सकता है, it may be. Try to solve this problem. The state of stresses at a system at a point is given in megapascal as this one. The yield strength of the material in tension 350 megapascal. The factor of safety according to MSST, please find it. Factor of safety according to MSST. Please, 2 minutes. Please find it. What is the MSST says that? MSST says that, sir, tau absolute max, this is equal to, what is that? SYT divided by 2 into factor of safety. Okay, yeah, SYS, or this is equal to SYS, or this is equal to SYS divided by factor of safety. Why? Because we know that in a tensile test, when you do a tensile test on a UTM machine, the SYS is equal to SYT divided by 2. We will prove in this, while the lecture we will prove, no problem. So this is your MSST. What is the absolute maximum? Absolute maximum is tau absolute maximum. It is your magnitude of maximum principal stress and minimum to minimum minus sigma 3 divided by 2. So if you differentiate maximum minus minimum, automatically this is maximum. So this is your maximum shear stress theory. Now for a given state of stresses, this is your given state of stresses. In this given state of stresses, what is that, beta? Sigma x is equal to 50, sigma y equal to 0, tau xy is equal to 10, and it is given yield strength, that means SYT, it is your 350 megapascal. Okay, 350 megapascal. Now, so you have to find sigma 1, sigma 2. Sigma 1, 2 is equal to sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau xy whole square. Put this value here. So, from if you solve, this is sigma 1 is equal to 51.9 megapascal, sigma 2 is equal to 1 minus 1.9 megapascal. Put this value. So, this is your maximum and this is your minimum. Put this value here. So, tau absolute maximum equal to mod of sigma 1 minus of minimum sigma 2 divided by 2. What is this value? This value is your 51.9 minus of minus 1.9 divided by 2. So, this is your 26.9 megapascal. Correct? Now, equate this one, that means tau absolute max, this is equal to SYT divided by 2 into factor of safety, and this is given 26.9 is equal to, what is SYT it is given? 350 divided by 2 into factor of safety. So, factor of safety is equal to 6.5. Clear? Clear everyone? Correct. Rohan, correct beta. Clear? Clear everyone, please? Rahul, try to solve, no problem. Take your time. Take your time. Clear? Correct. Okay. So, that is clear. Now, next problem. Try to solve this problem. Before that, you have to take a one note here. That is the note. Before that, one note is that. What is the note is there? You have to, along with, you have to try to also revise the formula also. What is that? Take this one. If SYT it is given, SYT it is given, yield tensile strength is given. So, tau maximum, absolute maximum is equal to SYT divided by 2 of factor of safety. Clear? Okay. If SYS is given, yield strength it is given. So, in this condition, tau maximum is equal to SYS divided by factor of safety. Clear? So, from these two relation, you can say that, sir, SYS is equal to SYT divided by 2. Remember. Clear? Now, next one. Please try to solve this problem. Try to solve beta. A shaft carry a torque of 15 kilonewton meter and bending moment 10 kilonewton moment with a factor of safety 2. If the same shaft is subjected to a torque, same shaft, same condition, same shaft is there. The condition is differ. The torque is 7 kilonewton and the bending moment is 5 kilonewton. Okay. That means you can reduce the load. The factor of safety in this case according to Tresca failure theory. What is that Tresca theory? Please find it. Nebraska theory of failure. MSST. Okay, please find it. 2-minute time. There are two shafts is there beta, and in this two shaft, first condition is given with a factor safety it is given. Second shaft the condition is given, same second shaft, the same shaft the given, but the second condition, the loading condition is differ. So accordingly, what is the design, how much you have a design factor, that means what is the factor of safety? Clear? Take your time, no problem. Okay, done. Now, so condition first it is given. Torsional moment it is given 15 kilonewton meter. Bending moment it is given 10 kilonewton meter. Factor of safety of this condition it is given 2. Condition second, it is given torsional moment it is given 7 kilonewton meter. Bending moment it is given 5 kilonewton meter. Then you have to find factor of safety of 2. Okay. So we have to try to solve equivalent bending moment. So equivalent twisting moment, you have to find shear stress, na? Shear stress according to maximum shear stress. So maximum shear stress you have to find a twisting moment. So equivalent twisting moment for the first case, T equivalent for the first case is equal to square root of bending moment plus torsional moment square root. If you put this value here, this is your 10 square plus 15 square. What is this? 18.02 kilonewton meter. From this one you have to find T equivalent to, so if you find T equivalent to, this is your 8.6 kilonewton meter, correct? 4.19, clear beta? This is clear. Now according to MSST, what is that? Tau maximum is equal to 16 T equivalent divided by pi dq. Okay, and this tau maximum is what? SYT divided by 2 into factor of safety. Yes or not? 2 into factor of safety. So here T equivalent is inversely proportional to the factor of safety. Yes or not? So T equivalent first divided by T equivalent second is equal to factor of safety is divided by factor of safety of 1. Clear? So T equivalent first is 18.02, T equivalent of second is 8.6 is equal to factor of safety of 2 divided by factor of safety of second first is equal to 2. So from here factor of safety of 2 is equal to 4.19. Correct? Correct everyone, please tell me. Rahul, wrong beta. 4.19, 4.46, it is wrong. Factor of 4. How? 4.19, correct. Rahul, correct. Rohan, correct. Clear beta? This solution, please tell me, are you solved according to this या other method? Please tell me. Very truly, Rohan, Rahul, please tell me, reply in the box whether you have to solve according to this method or is there any other method you have to apply. Please tell me, the same method you have to apply or any other method. Please tell me. Please tell me beta, the same method or any other method. You have to apply same method or any other method beta. Correct. Next, try to solve this problem. A structural member under a loading has a uniform state of the plane stresses, which is usual notation sigma x, sigma y, plane, that means 2 dimension, plane state of stresses, sigma x, sigma y, that means this state of stresses is given. This is state of stresses x, y, this is sigma x, sigma y, tau x, y, like that it is given. Where P is greater than 0, that means this is a tensile in nature. Okay. The yield strength of the material, it is given 350 megapascal. If the member is designed using maximum distortion energy theory, the member is designed according to MDET, then the value of P at which the yielding start. What is the value of P at which yielding start? Please try to solve 2 minutes. Try to solve beta. This is a plane of state of stresses, sigma x, sigma y, it is given. Please find it. Please. What is the load P it is? This question is little bit calculating, but the simple question is there. Very simple. Okay. To take a time 2 minutes. Structural member under a loading has a uniform state of plane stresses, which is usual notation is given by sigma x, sigma y, and the torsional shear stress root 2p. P is outside from the square root. P is positive, that means tensile in nature. Yield strength of the material is given. If the member is designed under a maximum distortion energy theory, what is the value of P? Okay. Okay, beta, I will start this problem. So, MDET, what is that? Sigma YT, SYT divided by factor of safety, this is equal to a square root of 1/2 sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. Clear? Okay. Here it is given sigma x is equal to 3p, sigma y is equal to minus 2p, minus 2p, oh, y it is in this nature, negative, y it is negative, okay. minus 2p and tau xy, it is your root 2p. Yield strength, it is given 350, and just a start so that you take factor of safety is 1. This see, yielding starts. Okay, we have to find sigma 1, that means sigma A, sigma B. Put this value, sigma x plus sigma y by 2 plus minus square root of sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, P is your 77. No, I have 70 megapascal. P, it is your 70 megapascal. No problem. This is which type? This is, I think, NAT type. Okay. Okay. Put this value here. Please check it. 3p minus 2p divided by 2 plus minus square root of 3p plus 2p by 2 whole square plus root 2p whole square. If you arrange like that, 1 by 2 p plus minus root 33p. So from here, sigma A B, it is your 3.375p comma minus 2.375p. So sigma A and sigma B, it is right. Please match it. Please with a match this one. Put this value here. So sigma 1 is there, sigma 2 is there. Put the sigma 3 is 0. So one component is 0, 2 dimension. So if there is a 2 dimension, SYT divided by factor of safety. Plus put this value here. So 2 dimension sigma 1 square, that means 3.375p whole square plus sigma 2, that means minus 2.375p whole square minus of sigma 1, that means 3.375p into sigma 2 minus of 2.375p. Rearrange it. Factor of SYT, it is given 350. Factor of safety is 1. This is equal to 3.375p whole square plus 2.375p whole square plus 3.375p 2.375p. Okay, rearrange it. 11.4 p square plus 5.64 p square plus 8.015 p square plus 350 whole square. This is equal to 25.055 p square is equal to 350 square. So P is equal to 350 by 20 divided by 5. This is your 5 approximately. So this is your 70 megapascal. Clear? This is your 70 megapascal. Clear, beta? This is clear? This is clear? Clear? 70 megapascal. Oh, yes, Rohan, yes, correct. I understand. This is the calculation mistake. I know that. Next one, try to solve this problem. This is a previous year, this is a very good question, and this is your gate question, okay. A bar of a square cross section and circular cross section. So this is your bar, okay. This is your bar of a square cross section and circular cross section with a 0.5 meter length are made of a material with shear strength 20 megapascal. The square bar cross section it is given 4 centimeter, 4 centimeter, and cylindrical bar cross section it is given. The specimen are loaded as, first one is tensile, second one is compressive, same load, third one is torsional, and fourth one is the bending. Pure axial pure tension, pure compression, pure torsion, and pure bending. Which specimen will fail due to the applied load as per as the MSST? Option it is given: torsional load specimen only, tension and compression load specimen only, bending load specimen only, या none of the specimen. Clear? Clear beta? Question is clear? Now take a 2-minute time. Please check it. Please check it. Which member is to be fail? And you have to justify your answer with respect to MSST. With respect to MSST. Okay. Okay. Please start. So this is your cross section given. First cross section it is given rectangular, and this is your 4 centimeter. 4 centimeter. Then there is a circular cross section, and that have a diameter 4 centimeter. Okay. We have to design MSST, and what is the MSST? Tau max is equal to sigma 1 minus sigma 3 divided by 2, and this is equal to SYS. You can write like that. MSST. What is that? Tau max is equal to sigma 1 minus sigma 3 divided by 2. This is equal to SYS divided by factor of safety, and this is equal to SYT divided by 2 of factor of safety. Okay. Okay. Now, case first. Case first is your bar, and we have to apply the load 80 kilonewton only. Okay. So what is the shear stress? This load divided by cross section area. What is the load? 80 cross 10 to the power 3 divided by area 40 into 40. Why? Because we take in mm. So this is your 50 megapascal. This is your 50 megapascal is the stress. Now, so in this case, this is a tensile. So this is your only one stress is there. That means this is tensile in nature. No any torsion is there. That means this sigma 1 is equal to sigma, and this is equal to 50 megapascal, and other two stress, principal stress, that means sigma 2 is equal to 0 and sigma 3 is equal to 0. So if we find tau max is equal to sigma 1 minus sigma 3, so sigma 1 it is your 50 minus 0 divided by 2, so this is your 25, and this 25 megapascal is greater than, tau absolute is greater than your the given value. What is the given value? The this material made of a shear strength 20 megapascal. A and B, shear strength 20 megapascal. So this is your greater than 20 megapascal. So this is greater, that means fail. That means fail. Right, Rohan, right. Now the second one is, this is your bar and you apply the compressive load same 80 kilonewton. Okay. So this is your same sigma is equal to minus 50 megapascal if you calculate. So sigma, so this is your minimum. So sigma 1 is equal to sigma 2 is equal to 0, and sigma 3 is equal to minus of 50 megapascal. So if we find tau absolute max is equal to sigma 1 maximum minus of minimum divided by 2. So this is how much? Sigma 1 is 0 minus of minus 50 divided by 2. So this is again 25, which is greater than 20. So fail. So B is also fail. B is also fail. A is plus 25, B is minus 25. C, very good, Rohan. And C is what? C is your 16. Okay. And what is D? Just calculate D. Very good, Rohan, very good. And A, B, C. What is the C? C is your torsion. C is your torsion. And this torsion is MT is your 64 pi Newton meter. Okay. So tau max, if you find, this is 16 MT divided by pi dq. Put this value 16 MT is your 64 pi divided by pi, and D is your 40 pi power q. This is your 16 megapascal, which is less than 20. That means safe. That means safe. Rohan, what is D? Okay, now we have to calculate for D. To calculate for D, we have to calculate for D. So D again. What is D beta? Again, there is a bar, and in which there is a bending moment. It is your 320 Newton meter. So if you find sigma B is what? MBY divided by I. So MB is your 320, Y is your D by 2, that means 20. This Y is equal to D by 2, that means 20 divided by moment of inertia, BDQ upon 12, BDQ upon 12, that means 40 pi power 4 divided by 12. This is your rectangle. Multiply with 10 to the power 3. Why? Because we have to find mm. So this is 30 megapascal. This is your 30 megapascal. Okay. 30 megapascal. Now, but the shear strength it is given. So we have to find tau max. This is sigma b. So other is 0. So tau max is equal to sigma 1 minus sigma 2 is 0. 1 is 0. So this is your 30 minus 0 divided by 2. This is your 15, which is again less than 20. So this is your safe. Clear? Tau max in this condition is Rohan, you are wrong beta. Tau max in this condition, this is your 15. Rohan, 15. Rohan, you are wrong. Previously you have written wrongly. Okay, so maximum it is your 15. Clear? Megapascal, not 30. Okay, so just so that don't put up rhythms. If this is your maximum, why? Because you have to compare with the max stress value. This in this question, this is given a stress value. It is okay. Shear stress is given. A is 25, B is 25, C is 20. Correct, Rahul. Very good, beta. Very good. Okay. Clear? Now, next one. Next problem. Try to solve this problem. A bar of a diameter 40 mm is subjected to a following loading. If SYT of this bar yield shear strength in tension is 240 megapascal, find the factor of safety using DET, distortion energy theory. Okay? Factor of safety you have to find. Clear? Just try. 2 minutes. Just try beta. Factor of safety you have to find. L shape the bar is given. This is 150 and this is 200, and the load is applied 4.5 kilometer. Okay, that means we have to find first the critical section. Where is the critical section? Where is the critical section? And we have to find the factor of safety according to MDET. Please find it. Okay. Now, so this is your bar. This is your bar beta. Okay, no problem. We'll take this one. Size will little bit reduce. Okay. This bar, it is in L shape. Okay, this is your bar and this end is fixed. Okay, so and this axis, this axis, this is your this axis, one axis is this one, other axis is this one. This is in plane, in the plane mode. And so this is your axis parallel to this one, and another is y axis. Okay, so this is your axis. This is your, so if you take, this is your plane. Okay, so this axis is perpendicular to the plane. Let's suppose Z axis. This axis is perpendicular to the Z. Let's suppose this is your Y axis, and this is your X axis. Clear? So this is also your X axis. Clear? First have a axis, otherwise there is a very big problem. This A, it is given 200 mm, and this L, it is given 150 mm. Okay, and here we have applied the load F is equal to 4.5 kilonewton. Okay, let's suppose this is a point P, where P we have to apply the load. Okay, now my dear, in this one there is a two type of loading. In this member, at this member, this load according, see, this is the horizontal. So this is your horizontal member, and this is also horizontal member. But this horizontal member which is along the Z axis, due to this load is eccentric, so it will produce, in this one it will produce a torsional moment. And also due to this load, if you shift this load at here, so this also produces a bending moment. So in this bar, that horizontal, this bar which is along the Z axis will feel two type of loading condition. First is the torsion, first is your torsion, and second is your bending. Clear? So this is your axis which is at fix. Okay, we have to I want to detail solution. What is the answer? No, wrong. Rohan, wrong. Answer is wrong. Rahul, you are right. 1.7. Rahul, you are right. 1.7. Rahul, correct. Okay, so this is your, first try to solve. Please see very carefully. This is your Z axis, yes or not? This is your Z axis. This is your Y axis, and this is your X axis. Okay, this is a fixed member. Okay, so in this one, Z, Y, and X. And now due to this load, it will try to twist in this direction, twisting, MT. So in this direction, that means this is anti-clockwise. So at the fixed end there is a, so at this, so it will try to twist. So in this direction there is a twisting moment. This is your twisting moment. In this one, this is your twisting moment, and this is your MT, resisting. Okay, and due to this load, let's suppose this load will try to shift here, imaginary load, and due to try to shift this load here, so this is cancelled. You try to shift load this here and try to shift this load. So this load also produce at this fixed end is your shear. So at the fixed end, at this end, it will produce a shear force also due to this load. So due to this load, this produce MT, and this produce this F is equal to V. V is your shear force. That means parallel to the given cross section, and this is your transverse shear. It will produce transverse shear. It will produce transverse shear. Now, this bar, this horizontal bar, this bar which is along the z axis, this bar which is along the z axis, this is along the z axis, this bar, let's suppose this bar, one second beta, along this direction, okay, along this direction, it will produce, that means it will produce in this direction, this is z direction. So, in this direction there is a torsional moment mt, and this is your counterclockwise direction. So, in this direction, at this end, there is your, in this direction mt, anti-clockwise, sorry, clockwise, this is your clockwise. So, my dear, this is wrong. Many students get confused here. This is wrong. So, at this end, in this direction, this is your mt. Clear na? Here you have to pull it. So, this is in this direction. At this end, it will produce a clockwise direction. Clockwise. So, at a fixed end, it is anti-clockwise. Clear? Sometime. And here, in this direction, there is a shear stress F, parallel to this one. This is your F. Okay, and this F, this is your mt. Okay, this is your done. Mt, done. This is done. Okay, that is done. Okay. Now, and there must be this force, this F force is there, shifting force. It will produce a bending effect. So, my dear, this is your cross section. This is clear. This force is clear. Force diagram. That is very clear. This is clear, beta. This is very important. I am telling you. It is not very difficult. This is very clear. Okay. Why? Because you know the nature. Now, for the bending, this is your bending effect. That means this is your shaft. Okay, this is your shaft, and this shaft is fixed at this point. So, and this end there is a force is applied F. So, it will produce a bending effect MB in this direction. So, here it is in this direction, there is produced bending effect MB. Clear? This is your x axis and this is your y axis and this is your z axis. So, bending it is in which axis? X axis. Bending will produce about x axis, twisting will produce about z axis. So, twisting will produce about z axis, bending will produce about x axis. Clear? So, if there is if you take a cross section, of this bar, so if you this is bending, so this is your tension, this is your tension and this is your compression. Why? Because it is tilted like that. So, this is your tension. So, at this end, top end, there is a tensile nature, and at the bottom there is a compression nature. Okay. Now this is your fixed end. If you made a fixed end, so this is your fixed end, there is a, this is your cross section of a fixed end. So this is your, one second beta, one second. This is your z axis, this is your y axis, and this is your x axis. Z, y, x. So here in this direction, that means about z direction, in this one it will produce twisting moment about z direction. In this direction it will produce bending moment, MB at a fixed distance, at a fixed point. Twisting in this one, there is a twisting and there is a binding about z axis, sorry, x axis, and there is a shear force, there is a shear force in this direction. This is your direction of shear force F, shear force V, which is equal to F. Clear? All the forces are clear. In this direction, here it is your MT, here it is your MB, here is the shear force. Clear? Now, this shear force will try to produce a bending effect, but the bending effect due to this shear force is very minimum as compared to the stress produced by the torsion, twisting moment, and stress produced by the bending moment. So this force, due to this one, you have to neglect it, very important. Neglect it. Will produce shear due to bending. Shear due to bending, and the magnitude is approximately 1/100 of bending maximum. So it will neglect. So it will neglect that effect, you have to neglect it. Now my dear, so only effect is your twisting and your bending. Now if we draw the cross section of this point, this is very important diagram I am telling you. If you draw like that, here, one second, okay. If you draw like that, see this cross section, this is a cross section, this cross section, fixed cross section. So this axis, this is vertical, this is your horizontal, it is like that. Okay. So let's suppose this is you have to take this at this one, this is your perpendicular to this one, and this is your parallel. This line is your this line. So this is your parallel to this cross section, and this is parallel to this cross section. Parallel to this cross section, this is your x axis. Parallel to this cross section, this is your x axis, and this is your y axis. So this is your y axis. This is your y axis, and this is your x axis. No z axis. No z axis, like that. You have to think like that. Okay. So you are not supposed to be that. It is not. It is. You have to It is like that. You don't think it is not like that. So it is your cross section. So in this one, if you take a 4 point, that means at this element you have to take, let's suppose this is your one element here, another element is here, another element is here, and other element is here. 4 element you have to take. 4 element, 4 point. Now my dear, this element is your neutral axis, about the neutral axis. Why? Because this, see, this is your beam and this is your cross section. So this cross section, it is your perpendicular to the Z. This is what? Perpendicular to the Z. This cross section is perpendicular to Z, and this is your x axis, yes or not? This is your x axis. If you see, view in this direction. So this is your x axis and this is your y axis. So this is your neutral axis. So neutral axis is along the x axis, and at the neutral axis there is no any bending moment, bending stress. Bending stress is 0. Why? Because y value is 0. Bending stress my by I. So at neutral axis y is 0. So there is no any bending stress. So at this point, that means if this is your A point and this is your B point, so at this point there is no any bending effect. Why? Because it is light at a neutral axis. So there is no any bending effect, but there is a twisting. There is a twisting in this direction, MT. So there is a twisting moment. So at this phase, at this is your twisting in this direction. So at this phase, the twisting moment, twisting shear stress, torsional shear stress, it is in this direction. Here it is in this direction. Here it is in this direction. Here it is in this direction. This is torsional stress. This is torsional shear stress. This is your torsional shear stress. So this is your torsional, and here the top is tensile. So at the top, the tensile nature is, at the top there is a tensile nature. So at this, at torsional, so at this phase, perpendicular to this phase, perpendicular to this, so at this phase there is a bending stress in tensile nature. At this phase there is a compressive in nature. So at this phase, compressive in nature, both are perpendicular, is the bending, and at this phase there is a tensile nature, is the bending, and here there is no any bending effect. That means sigma B at A and sigma B at B is equal to 0. Why? Because it is lie at a neutral axis. So at this point, that is, if you take, this is your top, this is your cross section. So at this point and this point there is a critical section. Why? Because at this and this point there is a maximum stress. There is a bending stress also in tensile and torsion stress. Here bending stress in compression and torsion is there. Here only torsion is there, here only torsion is there, no bending. So the critical section is, let's suppose this is A, B, C and D. So critical section is C and D. This is your critical section. C and D is your critical section. So my dear, so what is the bending stress maximum? So here the bending stress maximum in tensile nature, here the bending stress maximum in compressive nature, both magnitude wise same is what? 32 MB divided by pi dq. What is this value? 32. What is MB beta? MB F into this L. So F into L divided by pi dq. Put the value 32. If it is your 4.5 cross 10 to the power 3 L it is your 150 divided by pi, D it is your 40Q. How much it is? It is your 107.3 megapascal. This is your maximum bending moment. This is your maximum bending moment. Now my dear, what is the maximum shear stress? Tau max. So tau max, it is your 16 tau pi dq. Put the value 16, and here tau, torsion will produce due to this effect. This is torsion. It will produce torsional length. It is your A. Torsion. It will. Why? Because torsion will produce in x direction. X. So x at this point there is a torsion. The torsional moment is A. So here F into A divided by pi dq. So 16 F, it is your 4.5 cross 10 to the power 3. A, it is your 200 divided by pi d 40 per power q. How much it is? 71.6 megapascal. Clear? Clear? 107. No. Now, so at a point C, C is your top. So at point C, what is the state of stress? At point C, this is sigma x. Sigma x. Why? Because bending will produce along x axis. Bending will produce along, so sigma x is there. This is C, and there is a torsional stress, tau xy. There is no any y is equal to 0. And this sigma x is equal to sigma b max, and this tau is equal to 71.6 megapascal. If you talk about at point D, this element is D, so at point D there is a compressive in nature, but same magnitude. That means this is your sigma x, and this sigma x is equal to minus of sigma b max, and this is your tensile in this direction. Okay, so here it is shear stress. Now, so what is the average value? Sigma x plus sigma y by 2. This is your 53.6 megapascal. What is the maximum? Plus minus square root of, yeah, you can find sigma 1, sigma 2 from this one. So sigma 1 and sigma 2, if you find sigma 1, you have 143 megapascal principal. Sigma 2, you have to take 0, and sigma 3 is minimum, which is your minus 35.9 megapascal. So sigma 1, sigma 2, sigma 3 you have. Consider directly shear. Directly shear, what shear beta? Directly shear, this one. Directly shear. Rohan, if you consider direct this value, direct shear, oh, direct shear is this one. Direct shear, this is for the direct shear. Transverse shear is the direct shear, but it is negligible. Direct shear, how direct shear is due to this one? It is negligible. You have to find a bending moment and torsional moment. If you have an answer, what is the answer? You can say you are right, no problem. That is okay. I know that, okay? That is okay for that one. But I will follow the procedure, okay? Find the torsion, how to find this one. Why? Because in the examination, why? Because at this time, beta, there is IISc Bangalore question is setting. So any type of the question will create a confusion. So go with the proper guidance, not shortcut method. IISc Bangalore, you check your, if you try to check your level, please try to solve 2008 problem, 2008 and 2016. This 2 year IISc Bangalore. Check the level. It is not a direct. Go to the procedure. Okay, direct it is okay, no problem. So sigma 1 and sigma 2 you have. Once sigma 1 and sigma 2 you have, you can directly find MDET. So SYT divided by factor of safety is equal to square root of sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. Yeah, 3. Here 3, the 3 is there. Put the value from here, you can find factor of safety is equal to 1.7. Clear? Right. Now, so this is all about the static loading. Now, the next question is this one. Try to solve this question. This is, now there is a design against the fluctuating. One question come like in the SOM, no problem. But the factor of safety you can design on, no problem. You can solve like that, no problem beta. No problem, you can solve. But I will proceed with the machine design. Traditional method, how to find one, all the things, okay. If you have satisfied with your solution, you can go through, no problem. Yes, yes, but in the SOM, the design, that means theory of failure is the part of machine design, it is not a strength of material, okay. You are study the strength of material also, no problem. You can solve, Rohan, no problem. Try to solve this one, fluctuating load, dynamic loading condition, design according to your dynamic loading condition. What is that? A machine part is form a cantilever, okay. Cantilever beam subjected to a fluctuating load as shown in figure. There is a fluctuating load 800 and 1600. The load vary, okay. The modified endurance, that means endurance limit, yield and ultimate strength it is given. Endurance limit, yield and ultimate it is given. The factor of safety of using the Goodman's relation. Please find it. Goodman criteria. Factor of safety according to as per as a Goodman criteria. Please find it. Find it beta. 2 minutes. Factor of safety. Please find it. So what is the Goodman criteria? Goodman criteria, it is your, okay. If you draw the line, this is what? Amplitude stress, this is your mean stress. This represents the dynamic axis, this represents the static axis. So this is your SUT and there is S endurance. Try to join it with a straight line, that is your Goodman. So what is the Goodman? Sigma M by SUT plus sigma A by SE is equal to 1 by factor of safety. This is your Goodman. This is your Goodman. So Goodman, it is your under SUT condition. Okay. Now this is your beam. Apply the load 800 to 1600 Newton. Okay. So here is the bending moment M. What is that? This variable load P, this load P and this length L into L. This is our cross section. This is our cross section. This is our neutral axis. This is your Y. This cross section is 12 mm and this is your 20. Clear? This Y, okay. And SE it is given 200 megapascal and SUT it is given 600 megapascal. Clear? So what is the maximum binding? P max into L, this is your binding moment, into Y. Y is equal to this y divided by I. Put this value. P max is how much? 1600. L is your 100 and y is your 20 by 2 divided by, this is your rectangle, 12 cross 20 ka cube divided by 12. How much it is? 200 megapascal. What is minimum? P minimum into L y by I. Put all this value. This is your 100 megapascal. Please find it. This is your 100 megapascal. This is your 100 megapascal. Now, so what is the mean stress? Sigma max plus sigma minimum divided by 2. Okay. So this is your 150 megapascal. What is the amplitude? Sigma max minus sigma minimum by 2. This is your 50 megapascal. Put all this value here. Factor of safety 2. Correct. Put sigma m here, sigma a here, SE, SUT. So factor of safety is 2. Correct, beta. Correct. Correct, Rohan. Correct, Rohan. Correct. Very good. Try to solve like this similar method. Yes or not? Clear. Next problem. Try to solve this problem. Try to solve it. A bar is subjected to combination of static load. A bar is subjected to a combination of static load 60 kilonewton and the fluctuating load 10, minus 10 and 90 kilonewton. The endurance limit of the bar is this one, SE. Yield strength SYT and ultimate strength SUT. The bar cross section is square with side A. If the factor of safety is 2, the value of A dimension he is asking in mm according to the Goodman criteria. Please find it. Please find it, beta. So this is the combination of static load, and what is the nature of the static load? What is the nature of the static load? Mean stress is 0. Yes or not? Mean stress is 0. You know this thing. Okay. Now, so if you draw the diagram, static load. If you draw the diagram, so this is your bar. No problem. 1 second. This is your bar. Okay. This is your bar, and this bar of a square cross section. Correct. Now, if you draw the diagram, for the static loading condition, what is the nature of static loading condition? If you draw the stress time versus, so let's suppose this is your stress and this is your time. So their mean stress is 0. Hi Sita, how are you? You are late, I think. Okay, you are late. Why you are late? Please. Hi Sita. Okay, so if you draw the stress versus time, so this is the static load. That means the mean stress is 0. The mean stress 0 and that load is independent with respect to time. So the load is, what is the magnitude is there, that is for the constant time. So the load it is like that. This is a constant load. How was the preparation, Ishita? Prateek sir, hello. Okay, now, so in this condition, the mean stress is 0 and what is the amplitude? What is the amplitude? That is your load. That means what is the, why? Because the mean stress is 0. So this is your constant. That means this is your constant stress. It will not change with respect to time. Now, don't say sorry. Don't say sorry, Ishita. You pay your fine. Okay. Now, if you draw that fluctuating load versus time, that fluctuating load versus time, please try to solve fluctuating load versus time if you draw. Now, my dear, second one is the fluctuating load, and that fluctuating load is vary between 10 to 90. Yes or not? Let's see this. That fluctuating load is vary between 10 to 9. 10 is minus and 90 is positive. So positive 90 to minus 10. That means if you draw, there is a, this is your time, no problem. This is your stress. So this is your minus 10, let's suppose, and this is your 90, let's suppose. So this is your 90 and this is your minus 10. Yes or not? Now you have to draw, the stress cycle. So what is the mean stress? The mean stress, it is your, at this point, this cycle, first 90, then it is like that. 1 second. This is a minus 10, 1 second. Minus 10, then 90. This is your cycle. This is your fluctuating load cycle. Clear? Now, if we add this to 1, my dear, please see, if you equal to, that means add. Now you add this one. Now, my dear, see this thing. If you add, this is the positive, and what is the here? This load is what? How much? How much this load is? The load is 60. So this is 60. So this 60 plus 90 is how much? 150. What area it is your? No, wrong. Not area, beta. This is, they are asking the dimension of this one. Oh, Rohan. Thank you, Sita. Rohan, they are asking the dimension, not area. Area. That is wrong. A is wrong. A, it is your, that's why this problem is very important. I am telling you. Don't take light. Okay. So, what is this? Then this is 10 and this is 90. If you add this to 1, this is 60 already, and now you add positive 90. So this is positive 150. Oh, this is positive 150. So there is a 150 is there. Now, and so how much this will shift? This is a minus 10. So 60 is positive. So 50 is positive 9. This is 60 minus 10. How much? This is positive, this is positive. So positive y is, positive direction is 150. This is 60 and this is minus 10. So positive is 50. So there is 50 also. So here there is 50. Here there is 50. So here there is a 50. Here there is a 50. So this is your 50 minimum, 150 maximum, and there is a mean is 160. So there is a mean, and that mean is 60. Now the cycle is like that. See the beauty. Now the cycle is like that. Okay. So this is your mean stress. and mean load you can say like that, and this is your maximum and this is your minimum. First tell me A is equal to root 2. No, not like that. Now so what is sigma max? Sigma max is F max by area. What is F max? Is your 150. This is your F max. F max, this is your F minimum. So F max is 150. 150 kilonewton, 10 to the power 3 area. Take A. What is sigma minimum? Please tell me. F minimum divided by area. What is F minimum? 50 cross 10 to the power 3 divided by area. What is the mean? F maximum plus F minimum divided by 2, that means 100 cross 10 to the power 3 divided by area. What is amplitude? F maximum, sigma max minus sigma minimum divided by 2, that means 50 cross 10 to the power 3 divided by area. Apply the Goodman relation. Yes. Mean is 100. No. Don't take mean. No problem. Mean is 100. Yes. So 100 divided by area. This is your F. This is your force, not a stress. Okay. This is all our force, beta. This is all. Why I am writing here? Why? Because it is very easy to explain. Otherwise, it is a force. Very good. Mean is 100. Yes, 100. Very right. Very right. Now, now modified Goodman. So what is the modified Goodman? This is your sigma A. This is your sigma M. This is your SUT, and this is your SE. Draw a straight line. What is that? Sigma M by SUT plus sigma A by sigma M divided by factor of safety. What is sigma M? Take 100, 10 to the power 3 divided by A into 100 divided by 600 plus 50 divided by 150 factor of safety, and this is 1 by 2. Factor of safety it is 2. So the area it is your 1000 mm square, and this is a rectangle. This is a rectangle. This is A, this is A, so area it is A square. A square is 1000. So A it is your 31.62 mm. Clear? Got it? Rohan, wrong. 31.62. Rohan, you are wrong. Clear? This is clear? Please tell me. This is clear or not? Please tell me, beta. This is clear now. Everyone, please tell me. Please tell me, beta, this is clear or not? Is there any problem? Please tell me. Is there any problem? Please tell me. Is there any problem? Please tell me. So better to draw the cycle than you have to very clear. Rahul, sir, stress repeat please diagram. Okay. Okay. And check with the Langer criteria also. No. The Langer criteria also, but there says that Goodman's. Langer what? SYT and SYT. Here is Goodman. No. I will just, this is correct. Answer is correct. Okay. Modified Goodman. Yes. So Goodman SUT. Now Rahul says that, Rohan, no. That is okay. That is okay. Rahul says that, sir, stress repeat please diagram. Okay. No problem. Now my dear, first is, see, I will repeat. See, first is a steady load. Okay, I will just explain, no problem. Again, I will explain for you, Rahul. Okay. Now, happy? We have to draw time versus load. So this is your load, this is your load, and this is your time. So first is the steady load, modified Goodman. First is steady load, and steady load doesn't change with respect to time, so it is constant. So this is your how much? How much it is given? 60. Clear? Clear? Now there is a repeated. There is repeated. So repeated in 90 degree, 90 positive or 10 minus. So if this is your force, so 90 it is here, and let's suppose 10 minus here. So this is your 10 and 90, and this is your minus 10. So this is your minus 10, and this is your 90, and this is your 60. So let's start with this one like that. This is your cycle. Clear? Now add this to 1. So if you add this to 1, this is time, this is F. Add this to 1. So my dear, if you add 9, this is positive 90 and this is positive 60. So positively it will shift how much? 150. So there is a 150 line. So this is 150. This is F max. Now minus 10, this is plus 60. So plus 50 is up. So this is plus 50. This is plus 50. So F minimum is 50. So maximum minimum you have. Now if you find the maximum stress, what is that? F max divided by area. If you find a minimum, F minimum by area. If you find a mean, sigma max plus sigma minimum by 2. If you find amplitude, sigma max, sigma minimum by 2. Apply relation sigma m by sy sut, sigma a by se is equal to 1 by fs. Put this value, find a it is your 31.64 m. Clear? Now it is clear, Rahul? Now it is clear, beta, Rahul? Now it is clear, please reply in the comment. It is clear, everyone, please? Okay, okay. Thank you, thank you, thank you. Now try to solve this problem. Just try to solve. I will give also the very good method for you. This is very good method for you. See, in this question, sometime the fluctuating it is given, but there is no any criteria it is given. Which criteria? Please read this question. A machine member is subjected to a fluctuating stress. Sigma is equal to sigma naught cos 8 pi t. The endurance limit it is given. If the factor of safety used in this one, the maximum allowable value of sigma naught in megapascal, please find it. 1 minute. Sigma naught you have to find. Please find it. Okay, please tell me which type of loading is this one? Cos function it is given now. And cos, sine, these are the alternating, yani pure repeating. Cos, sine, these all are the repeating. That means this is your purely alternating load. Purely alternating load. What is that? Sigma is equal to sigma naught cos 8 pi t. Okay. Yes, 100. Very good. Very good. Now, so it is like that. Now, if you draw, see my dear, purely alternating load, what is the characteristic, Rohan? If there is a purely repeating load, repeating load and alternating, what is the characteristic? Repeated load, what is the characteristic? Correct, correct, Rahul. What is the characteristic? Please, I will solve for the another method. I know that you try to solve. What is the characteristic of the repeating load? Repeated load, anyone please? What is the characteristic of the repeated load? Repeated load, what is the characteristic? Pure alternate, negative, positive, sign, cos graph. The cos is like that. What is the characteristic? Sigma mean is equal to 0. There is no any mean stress. 0 to maximum? No. Not Manda, Rohan. That's why I'm asking. Numerical solving is the another method. Interview question is the another method. Please, I am humbly request you, all of you, try to go with the concept. Yes, very good. Mean stress is 0. Okay, that means maximum is equal to minus of minimum. Clear? Now, if we solve beta, if you draw the line of mean stress on SN curve, how to draw? Please find it. My dear, SN curve, S and N curve, strength versus number of cycle will draw under which type of loading? Please tell me, Rohan. Meaning Rohan and Rahul, SN curve will be drawn on which type of loading? Please tell me. Static load or dynamic load? Please tell me. SN curve. Completely reverse. Okay. Static load or dynamic load? Static load condition. In a static load condition, SN curve is drawn. Number of cycle. Yes. Fluctuating load also. But, yes, you are right. But if the fluctuating load in the SN curve, fluctuating load, if the will draw the fluctuating load, but in that SN curve we can also draw the static load, but that means fluctuating or dynamic load, but that fluctuating and dynamic load will drawn if mean stress is 0. That means if you draw S and N curve, so this is your SN curve. So this SN curve corresponding 10 to the power 3 cycle. This is your 10 to the power 7, you know, and this is corresponding to sigma m is equal to 0. Very important. Yes or not? Sigma m is equal to 0. Okay. Now, if we have other than pure alternating, in that case sigma m is not equal to 0. Yes or not? Yes or not? This is theory part. Sigma m is not equal to 0. Sigma m is 0 pure alternating or steady load. Sigma m is equal to 0 is pure alternating or steady load. So in this case the mean stress 0. if the mean stress is less than 0 or mean stress is greater than 0, how to draw on this line on SN curve? Please tell me. If we draw, see my dear, so this is your, now this is your completely purely alternating, that means sigma m is equal to 0, this line, and we have to find, if the factor of safety we have used 3.5 and the endurance limit it is given, so this is corresponding to the endurance limit SE. Now if you apply the factor of safety, whether your point is above this line or below this line, please tell me, for the safe design. For the safe design, whether you have to move above this or below this? Below this. That means below this you have to design the cycle for infinitely cycle. You have designed the component for infinite cycle. That means this is your n less than 1, n greater than 1, sorry, n greater than 1. This is your n greater than 1 and this is fail n less than 1. So n greater than 1 for the infinite cycle, and this is corresponding to sigma A. And sigma A for the pure alternating is your sigma max. This is your sigma A. And this sigma A is sigma max. And this sigma A max is equal to sigma naught. Why? Because this is maximum. This is maximum. Function, this is maximum. Yes, below. That means if you find the factor of safety, which one is divided? That means SE greater than 1. For the greater than 1, divide SE by sigma A. Okay. So SE by sigma A, sigma naught, and factor of safety, it is how much it is given? 3.5, and SE is how much given? 350 divided by sigma naught. So what is the sigma naught? 100. Clear? Clear? Everyone please tell me. Clear? Clear? This is clear not? This is clear not? Please tell me, you are solving like this method or not? Please tell me, you are solving this like this method or not? If there is a nothing is given, which criteria you have to use? Please apply this concept. Clear? Yes or not? Please tell me. Please tell me, yes or not? Yes or not, beta? Please tell me. This is clear? This is clear, beta? Okay. Now, so this is the kind of fluctuating kind of this condition. Now we have to solve. Yes, very good. Now we have to solve this question. So this is the again MSQ type question. Please read this question. Please read the question and mark the correct. When the lubricating oil is forced between the journal and bearing by external pressure, the bearing is known as hydrostatic bearing. Second statement, in hydrodynamic journal bearing, there is a very thin film of lubricant between the journal and the bearing, such that there is a contact between the journal and bearing. Okay. Number third, summer field number is directly proportional to the load. Number four, the performance of a hydrodynamic journal bearing is a function of bearing modulus. Which of this statement is correct, beta? Which of this statement is correct? Please tell me. Which statement is correct? This is your MSQ type question. 2 mark. expected question in GATE 2024. All are correct. Anyone please? Anyone please? Rahul says that all are correct. Anyone please? Rohan? What's your answer? Please tell me. This is incorrect. Other than it is correct. Option is A, B and D. Rahul, you have a negative mark, 1/3. Clear? These are the definition of hydrostatic bearing. In hydrostatic bearing, the fluid is forcefully filled in the gap between two mating parts by the external agency known as pump. So when the lubricating oil is forced, so forced hydrostatic, forced hydrostatic. A hydrodynamic journal bearing, a very thin film is there between the journal and bearing such that there is a contact between journal and bearing is discontinuity. Summer-filled is inversely proportional to the load, not directly proportional. So here it is inversely proportional, it is there, then it is okay, but here proportional it is there, so this is wrong. The performance of the hydrodynamic journal bearing is a function of bearing modulus. That means Zn upon P. That means mu n upon P. This is your bearing modulus Z, bearing modulus K. And what is the bearing modulus, beta? Yes. What is the bearing modulus? What is the characteristic of a bearing modulus, please? Anyone? Anyone, please? What is the bearing modulus? What is the characteristic of the bearing modulus? The bearing modulus is a bearing modulus is a kind of number. That means this is your number. Non-dimensional thing is there. That means this is a number at which the friction is very minimum. The frictional force, the coefficient of friction between the two mating part is very minimum, that is at stable condition. So at a fully stable condition, the modulus is defined as a bearing modulus. Correct. Next one. Next problem. Try to solve this problem. Try to solve this problem, beta. The expected life of a ball bearing, this is a ball bearing. Expected life of a ball bearing subjected to a load of 9800 Newton and working at 1000 RPM is 3000 hours. What is the expected life of the same bearing for the similar load of 4900 Newton and speed 2000 RPM? Please tell me. What's your answer? Okay, read this question. Now, we take some tips for that one. See, we know that L10 rated life is equal to 60N LH, very important thing I am discussing, divided by 10 to the power 6. This is equal to C by P equivalent. My dear, for the gate, only this part of the bearing, only this part. Here, L10 is what? L10 is the rated life in million of revolution. LH is your expected life of the bearing. Expected life of the bearing in hour. Okay. This C is your dynamic load capacity. Capacity or basic dynamic load capacity. Basic dynamic load capacity, and always this is constant. This is constant. Why this is constant? Why? Because this is provided by the company. Okay. Please, what is your answer? Okay. And this PE is your equivalent static load, or you may say that radial load, or you can say that variable load. Okay. And this A have a value 3 for ball bearing and 10/3 for roller bearing. Clear? N is your revolution. Okay. Now, what is the given here? It is given ball bearing. So this value you have to take. Now they says that so this is constant, and this value is constant. This is constant value. So what is this relation? Always remember this thing. N LH into P equivalent, and this is constant. P equivalent by power A. Apply this relation for two bearing. This is very important things. Wrong. Rahul, wrong beta. What is the option? There is no any option is there. That means unchanged. Wrong. Wrong. Please apply this one. NLH, this is the relation. 60 constant, 10 to the power 6 constant, and this is always constant. So what is the relation? NLH PE पे power A equal to constant. Apply for the two bearing. That means first bearing, that means what is that? N into LH into P equivalent per power A is equal to constant. So first bearing, what is N? First bearing, what is N? 1000. 1000. What is LH? What is LH? 3000. What is equivalent load? 98 पे power 3 is equal to N for the second 2000 LH you have to find. Weight is your 49 by power 3. Find LH, one line answer. Correct? Yes, is correct. One line answer. One line answer, beta. Don't excited. I'm telling you, and this type of question always may be asked in the gate. So this is the question. Okay, no. Okay, this is the question. Clear? Don't use the very lengthy relation. No, use concept. This is your only formula for the bearing. If you know all the terms, you can easily get 2 marks. Correct, Rahul. Correct. Now the second one. Try to solve this second one. Try to solve this second one. Try to solve this second one, beta. Try to solve this second one, please, everyone. Try to solve, beta. Oh, 10/3 ले लिया था. अगर 10/3 ले लिया था तो नेक्स्ट ईयर आया था, फिर नेक्स्ट ईयर आएंगे आप. हद है. ओके, ऑलवेज रिमेंबर. क्लियर? नाउ रोहन, क्लियर बेटा? रोहन, this is clear. Now next one, this one. Try to solve this one. A natural feed journal bearing, diameter it is given, length it is given, okay, operating at 200 RPS, okay, carry a load 20 kilonewton, the lubricant is used at a viscosity 20 millipascal second, the radial clearance it is given, Sommerfeld number S. What is the Sommerfeld number? Okay. What is the Sommerfeld number? What is the Sommerfeld number formula, beta? S is equal to R by radial clearance whole square into mu n by P. Okay. Now, what is this P? This n is always take in RPS, number first. This is very important. Next one. This is your P is what? Bearing pressure. Bearing pressure. And how to calculate the bearing pressure? 0.2, 0.02. Wrong. Rohan, wrong. What is the option? Option wrong. Rohan, wrong. Yes. Bearing pressure. How to calculate the bearing pressure? Load upon projected area. What is the projected area? No. This option is correct. B. What is the projected area? What is the project? See, if this is your bearing, so that is your projected area. This plane is your projected area over which the hydrostatic pressure will act. Why? Because you know that hydrostatic pressure is what? If there is hydrostatic pressure acting on horizontal manner, hydrostatic fluid pressure, hydrostatic, that is your vertical projection, and vertical projection is a pi dl. Yes, very good, very good. That means W pi dl. Rohan, wrong. Rohan, wrong. Not ideal. That's why. That is the wrong. Very important. Rohan, if you are telling, that means you are wrong. The area is D into L, not pi dl. Where the pi dl use? When we have to apply the shear force. I will just tell you. You know this thing, D into L? Not pi dl. This is a very danger mistake. Danger mistake, I am telling you. Not pi dl. This is your bearing pressure. That means you don't know what is the bearing pressure. Yes, L into D. How the L into D? See, my dear. That is the very important thing I am telling you. We'll explain here. I will explain the question. We'll explain the theory part. Understood? Rohan, this is clear, beta? This is done, na? Bearing pressure, clear. Right. This is like that. Now put the value. So what is the given condition is there? Diameter of this bearing, it is your 50 mm. Length, it is given 50 mm. N, it is given 20 RPS. Radial load, it is given 20 cross 10 to the power 3 Newton. Viscosity, it is given 20 cross 10 to the power minus 3 Pascal second. Why? Because it is millipascal, it is given. Radial clearance, it is given 50 micron. Sommerfeld number, put the value. So first find the bearing pressure. What is the bearing pressure? P is equal to W by D into L. I humbly request you, please beta. Yes, correct. I humbly request you, please. हाथ जोड़ के हाथ जोड़ के this is D into L. हाथ जोड़ के, okay? D into L. Clear. So W, it is your 20 cross 10 to the power 3 divided by 50 into 50 mm 10 to the power minus 6. So this is 8 cross 10 to the power 6 Newton per meter square. Clear? So Sommerfeld number is equal to 25 divided by 50 micron. 50 cross 10 to the power minus 3 whole square 20 cross 10 to the power minus 3 into 20 divided by 8 cross 10 to the power 6. Solve this one. 0.0125. Clear? Clear, beta? This is clear, all the things. This is your R, it is your 25. This is your radial clearance. Radial clearance, it is micron. Put into mm. So mm. This is your what? 20 cross 10 to the power 3 mu into n. N, it is small, 20 divided by bearing pressure. Clear? Yes or not? Please tell me. Time is over now. Yes or not? Please tell me, beta. This is clear or not? Please tell me. This is clear or not? Okay. Please find the next problem. So I try to take a next session also. I will announce that next session. Why? Because today will not cover all the problem. So we'll try to solve the next one. Please try to solve. Yes, N भी RPS में लेना है. That is very important. That's why. हाँ. That's why star mark. Okay. If there is N in RPM, convert then put. That is very important, I am telling you. Okay. Try to solve this problem. They ask a ball bearing had characteristic by ball bearing. A is equal to 3. Ball bearing is characterized by the basic static capacity and dynamic capacity. Basic static capacity 11,000 Newton, dynamic capacity is 18,000 Newton. The bearing is subjected to equivalent static capacity 5,500 Newton. What is the life in revolution, million of revolution, that means L10? Please find it. 30 seconds. Please find it, beta. We know that. Please find it. Everyone, please. This is very simple problem. A ball bearing characterized by the basic static capacity is 11,000 Newton. Dynamic capacity is 18,000 Newton. The bearing subjected to equivalent static capacity is 5,500 Newton. What is the life of the million of revolution? Okay. First, what is the value of C here and what is the value of PE here? Please tell me, what is the value of C? Rahul, Rohan, what is the value of C here? What is the value of C here? Please tell me, everyone. What is the value of C and what is the value of PE? Please tell me. Everyone, please. What is the value of? Please tell me. Time is over now. What is the value of P and what is the value of C? I am telling you. What I am asking, that is the important thing. What is the value of C here? C. Okay. What is the value of PE? What is the value of PE? See here, C is your dynamic. So, static capacity it is given and this is your dynamic capacity. So, dynamic, that means C it is your 18,000 Newton. And the bearing subject equivalent static. So, this is your equivalent static, that is your 5,500. Correct. Correct. So, L10 is equal to C by PE pe power A. C it is your 18,000, PE is your 5,500. A is your 3. What is the answer? The answer it is your 535,053 million of revolution. Clear? Clear, beta? Everyone please tell me, this is clear or not? Everyone please tell me, this is clear or not, beta? Everyone please, this is clear or not? Everyone beta, please tell me, this is clear or not? Everyone please tell me, beta, this is clear or not? Everyone please. So now my dear, I will, yes, correct. I will end up here. And really, I enjoyed lot for this session. Okay, for 3-hour session, I never feel any type of boring in any situations. And you guys also very awesome. I know that who is present here and give the reply and reply continuously. Damn sure you have a very good score in upcoming examination. I am telling you, very good score. I know that. Because your speed is good and also I I will take next, and I will announce for that Telegram group also. So for that one, that is our beta, that is our Telegram group. That is our Telegram group, okay, in which the schedule for the free lecture all. So please join this Telegram group. If you join this Telegram group, all the updates are here. So please join this Telegram group. Okay, this Telegram group is there, and according to this Telegram group, that means all the things are there. What is the when the YouTube live is there, what is this today's lecture PDF is also uploaded here. Also important government notification is there, expert topics and daily quiz is very important for this one, to join for this one, to join this one. Okay, and there is also a IMS feature is this one. What is the IMS feature? IMS feature is that we have a 8,000 plus hour live classes with a live interaction, and theory book is there. Theory book very important. What is the uniqueness of theory book? In this theory book, beta, 30 plus year the question collection of the question with a solution, and there is a video solution. There is a video solution is there. Video solution. So this is very important things. And in the IMS future, there is a 12 personalized mentorship session, and there is a 130 online test series. There is the, if you know the more detail, you can join it. But the main thing is that whenever we have a next session, just I will we have to join. I will request you to join this Telegram group, so that all the notification you have to get. Okay. Up to that, till that, thank you. Bye bye. Take care.